Hello guys, in this video I will explain you about the difference between group by key versus reduce by key. Interviewer can ask you what is the difference between reduce by key and group by key. This is a very important question. You have to know this. We will write some code and we will try to understand the difference between group by and reduce by key. So let's start from theory. So both are transformation. What transformation? So reduce by key or reduce reduce by and group by key both are wide transformation. Wide transformation. So reduce by key and group by key both is working in the principal work, like what I am trying to say. The job of reduce by key and group by key is same. What they will try to do, if in our data set we have the data like this, hello comma 1, hello comma 1, hello comma 1. So if in our data set we have in our RDT we have a data like this, if I used group by key or reduce by key, at the end we will get hello comma 3. If I use reduce, if I apply reduce by key or reduce by or group, I can be used anything. We can use anything, but result will be same. So there is no difference in result. But what is it? The difference is internal working. Which what can we can say the which transformation is optimized. Okay, so that is the internal work. The difference between the reduce by key, group by key is the internal working. The output will be same. On top of this data set, if I use group by key or reduce by key, the output will be same for both operation. But difference is internal. Internally how they are working. In single word we can say the optimization of command, optimization of this transformation, which is the optimized transformation. So now we'll try to understand this part. So the optimized one is reduced by key. We should not use group by key first. We should remember it. We should not use group by key. Why? We'll deep down on this part, on this topic, on this part in later part of video. But you have to understand one thing. If we used reduce by key, we will get some advantage. The advantages are one. Advantages are more. Sorry, what is happening? Sorry for that. So advantage is more work in parallel. And second advantage is less data shuffling. Less shuffling required. So less shuffling is required and more work in parallel. So if I used our reduce by key, we will get this advantage. But these advantages are not present in group by key. Why? Now we'll understand. So I'll draw a diagram. So we have one diagram. So I'll draw one diagram. Let's so in reduce by key, so in group by key, group by key, if I use group by key, in group by key we don't have, remember this point, we don't have local aggregation. Aggregation. So, and all the key value pairs are sent to another machine. It means there the data sampling will be in full mode. The if we have a data in one partition, we will, if I used group by key, all those data will send to another partition. So there will be data sampling. But in case of reduce by key, there will be less data sampling. But in case of group by key, we have a full data sampling sent to another machine. Full data sampling. Full data sampling. So we have to shuffle. So we have to shuffle more data, and we get less parallelism. I'll explain why we are getting less parallelism. Parallelism. Now I'll draw one diagram. Okay. Let's think have a node 1, node 1, node 2, okay, and node 3. Node 3. Inside node 1 we have a one data called x comma y, x comma 1, y comma 1. In this data we have a x comma 1, y comma 1, x comma 2, sorry, comma 2, y comma 2, x comma 3, y comma 3, x comma 1, 1, x comma 2, sorry, x comma, sorry, I am doing one thing, everything will be 1, x comma 1, 1, 1, y comma 1. So we have 3 node, and I am explaining for group by. This is for group by. Okay, this is for group by. So we have a 3 node, and let's think we have a RDD, and the data of RDD is distributed on 3 node. So we have a 3 partition, you can say, or you think that we have a data set, and with this data set is distributed in the 3 node. Now we are using RDD. We are using group by key on top of the RDD. So RDD contains this dataset, and this dataset are distributed on 3 node. Now if I use, so you can say this is a 3 partition. If I use group by key on top of this RDD, on top of this data, what will happen? So in case of group by key, we are trying to sum the value of same key. It means y will be y comma 3. Here there will be y comma 2, like this we are trying to do. So if I use group by key, so it will try to, so there are 2 unique key, one is x, one is y. So it will try to move this data maximum 2 machine. So there will be another node or another partition where we will try, where this node 4 and node 5. So the group by key, what it will try to do, it will try to move this same type of data in a separate node, separate machine. So this data will come here, from here this data will come here, from here this will come here, like this. So let's think we have in this node we have only x data, x comma 1, x comma 1, from here will come x comma 1, x comma 1, x comma 1, and x comma 1. So all x comma 1 data will be here in node 4. All y comma 1 data will be here. Y comma 1, y comma 1, like this. Y comma 1, y comma 1. So like this. So what is the total value of x? Total value of the x will be x 1, 2, 3, 4, 5, 6, 6. And y will be 1, 2, 3, 4, 5, 6. Y will be 6. So this is the output after using group by key. But one thing you have to remember, we are shuffling this data. So all data of this person will go to different machines. So we are moving all those data into different machine. When we are moving all data from one person to another person, it will take time. The group by key can send this data into two different machines because there are two unique key x and y. Otherwise, it also can send all of this data into single machine. It's depend on the how it is working internal. But maximum it can use two node. So the main point, main aim is you have to focus on main thing. All data is going we are moving all data from one partition to another partition for group by key. So there is a full data shuffling, full data shuffling, full data shuffling. When you are trying to do the full data shuffling, it is not good for our parallelism, because using big data, using Hadoop or using Pyspark, we want to execute our job in a distributed way so that we can achieve parallelism. But here that parallelism is, we are hurting this parallelism concept, because think we have this three node but we are not using. So in our cluster we have a 5 nodes, and initially we have a data in 3 node. Okay, now we are not using this 3 node, we are not using this, we are abandoning this 3 node, and we are trying to move those data from 3 node to this 2 node. So these guys have to do more work. This node 5 or node 5 will work more, and these guys will be idle. That is not a very good thing. Okay, so if I use this, so the main point we have to note it down some point. So full data shuffling for group by, if I use group by, full data shuffling. Second, less parallelism. These are the parts. So that's why you don't have to use group by key. In industry, people don't use group by key. That's the reason. Now, if I see another example for our reduce by key. Now what I can do? So I will use this picture only. So group by key here. No, I will another picture. So let's think we have a data here, x comma 1, y comma 1, x comma 2, y comma 2, x comma 1, y comma 1, x comma 1, y comma 1, x comma 2, and receiver node 1, node 2 is there. node 3, node 2. This is a node. Now, if I use group by, so if I use reduce by, what will happen? Reduce by key. So we have one entity, and on the so we have one entity, and that entity have three partition, and those data are distributed into three machine, and those data look like this. And if I use group by key, sorry, reduce by key. If I use reduce by key, what will happen? Reduce by key will used to do will use the local aggregation. It is like a combiner. In MapReduce, you know the combiner concept. It will try to aggregate the value in mapper side. Similar like this, if I use reduce by key, what will try to do? It will try to before data movement. It will try to do. It will try to aggregate locally. Inside node 1, it will try to do that. It will do how many x are there. So it will try to calculate. X comma 2. We have total x comma. So x is present 2 times and y is present 2 times. It will try to aggregate locally. For node 2 also it will try to do local aggregation. So x comma 3 and y comma 3. For node 3 also it will try to do x comma 1, because it is already only 1, so there is no point of doing aggregation here. Okay, so this is the node 1, this is the node 2, this is node 3. Now reduce by key will try to shuffle this data. So we have another node called node 4 and node 5. So data will come from here, data will come from here, data will come from here, like this same. But remember one thing, now we will get data like this, x comma 2, x comma 3 and x comma 1 here, y comma 1 here, y comma 3 here, y comma 2. See the difference. Now we are getting small data. Here is also for reduce by key, data shuffling is there, but we are shuffling less data because we are doing local aggregation here. Now we are shuffling x comma 2, y comma 3, x comma 3, y comma 1, x comma 1. If you see the reduce by key, sorry, group by key, we are shuffling this many data. This is for group by key. Now for reduce by key, same thing, but we are shuffling less data because we are doing local aggregation here. Okay, if you see also for node 5, this is for reduce by key. We are shuffling this much of data, x comma 1, y comma 2, y comma 3, y comma 2. Now if we come here we are shuffling a lot of more data. So in reduce by key, we are shuffling less data, and we are doing local aggregation on this mapper side. I mean this on this partition. So we are doing the more parallelism work. So we are doing more parallelism work and less data shuffling than reduce by key, than group by key. So that's it. So that is the main funda for reduce by key and group by key. Now let's think one scenario. If I have 1000 node cluster, and I have this RDD. I have this RDD. I have one node 1000 cluster, and we have 1 TB data. So 1 TB data, and if I divided by 128, so how many blocks will be there? 8000 blocks will be there. 8000 blocks will be there. So RDD. So RDD will have what is happening. So we have a 8,000 block means 8,000 partition. Number of blocks will number of partition 8,000 partitions. This one. And I have 1,000 node. So if I divide by 1,000, it will be so each node will have 8 partition. Each node of each partition. So one RDD will hold 8 partitions. So each RDD will have 8 partition, and each node will hold 8 partitions, and one RDD will hold 8,000 partition. Now think I have to use group by or reduce by key on top of this data set. Then what will happen? So data is like we have this, say TV, and the date. I purchased this TV on this date. Mobile, I purchased it on this date. So this is on node 1. There is a different one. We have another node called TV, different date. Like this, we have a purchase order and our purchase item and the date. And this is distributed among our 1,000 cluster. So we have a 1,000 node 1,000, and those node is containing this type of data. Now if I use group by key, and in our dataset, if I have only two key in a unique key, when I say two unique key means TV and mobile. Those are key, two unique key. So the group by key will try to Group by key will try to shuffle this data, and it will try to send this data into maximum 2 node, because there is a 2 unique key. So it can say all TV data will come to this node 100 or something, and all mobile data will come here maximum. Otherwise it comes to say all those data, mobile and mobile TV data, into single nodes. It will depend on the how internally it is working. So node 101, something like this. This is mobile, this is TV. So see, we have 1,000 node after using group by key. This is group by key. Group by key. We are shifting. We are moving all those data into 2 node, and this 2 node will be on what? This 2 node have to work more now, because now if I use group by key on this data set, so initial RDT one has 8,000 partition and 8,000 partition, and this is distributed among the like 100 cluster. Now when I use group by key on top of this RDT1, I am getting RDT2. But main point is here, this RDT2's data is distributed on only 2 partitions, only 2 machines. So the whole RDT2's data, whole 1 TB data now stored in only 2 machines, 2 nodes. So what will happening now? If I again use some transformation, and then we will also get another RDT3. But this this transformation will happen where only these two node, because we have data only on these two node. Other nodes will be idle. So other 900 980 node will be idle. Only on those two node, only only on those two nodes our job will execute. So this is not this is what we, this is not a good, because we want more parallelism. Because if we have a cluster, we want to divide our work, we want to divide we want to divide our work among, like, we want more clusters so that we can achieve parallelism, so that our job will execute fast. We don't want to overburden one single node. What should be our aim is that we should divide our work, and we should distributed our work on on more machines, so that we can get more fast execution. But here is opposite. We have a 1000 node, but after using group by key, those data is coming into only two nodes. So only those two nodes is holding 1 TB data. And now if I use another transformation, so those job will execute only on those only on those two nodes. Okay. So only on two rows. So it can say only two partitions. You can say only two node means only two partition. So one thing, this partition, where will be this partition? This partition will be in our RAM, because this is Spark. So it can lead us out of memory, because one single partition, for every partition we have a size. We mentioned some size. Okay. So if we store more data, like lot of data in single partition, in single node, that time we can, like, the Spark can give us throw us a out of memory issue. Out of memory issue. So remember one thing, interviewer can ask which operation, interviewer can ask you that which transformation give us out of memory error. That will be the group by key, because it will try to store all those data into singular maximum, like singular. It depends on number of unique key. So maybe two, maybe one nodes. So when you are storing 1 TB data only in two nodes or a single node, so we can get out of memory error, because for node 1 there will be some memory capacity. We cannot store the unlimited data in node 1. We have some storage allocation. We allocated some storage. Let's think 500 MB. We cannot store more data than 500 MB. So when we are storing data more than 500 MB, we will get out of memory error. So this is the common, like, if we are working with big data set, and we are using group by key, we can get out of memory issue. But in case of reduce by key, what will happen? So reduce by key, we have a node 1, we have a node 2, and then we have a node 1000, and node 1000. So here we have a I one, sorry, TV one, mobile one, same TP one, mobile one, same. We have data like this. So we have a two unique key. Now if I use group by key, let me write mobile one, TV one, TV one. Now if I use group by key, it will shuffle the data. Before shuffling the data, it will try to do local aggregation. It will try to see in node 1 how many mobile is there and how many TB is there. In node 1, let's say we have a TB only 2 times, mobile only 1 times, TB only 1 time, TB is 2 times, in for node 2, mobile is 1 time. Mobile is 1 time. TV is 50 times, let's say, mobile is 100 times, 1000 times. And it will try to supply only this much of data. Only this much of data, not whole thing. It will try to supply only this much of data. It will try to supply only this much of data. It will try to do a local aggregation. When you are doing local aggregation, the data size will reduce and it will try to shuffle this data on two partitions, on two machines. The TV data will come here only and our mobile data will come here. And then we will get the total output that we have a TV or we have a total TV 1000 or a mobile we have a 1000, something like this. We will get output. So when we are using reduceByKey, the data sampling will be less here. That is the main point. The industry expert always prefer reduceByKey because we are sampling less data. When we are sampling less data, it will take less time to execute. Also, you are doing more parallel work, more parallel work. Why? Because we are doing map site or what is a map, so like this is like you can think as a combiner. We are doing map site aggregation. We are doing this aggregation on 1000 cluster, so we are achieving parallelism. But in case of groupByKey, we are doing aggregate on this two machine only. Only on this two machine. So we are not doing parallel work here, but we are doing this aggregation on 1000 machine, and for groupByKey we are doing aggregation on only in these two machines. That's why we always prefer groupByKey and over. That's why we prefer reduceByKey over groupByKey. You should remember one thing. If in your dataset, if in your dataset, if in your dataset you have 3 unique key, so if you use groupBy and reduceByKey, then your data can store inside 3 machine or less than 3 machine after data sampling. Okay, that's the more important thing. So if you have, if in your dataset you have 3 unique key like TV, mobile and tablet. So after data sampling, your data will store maximum 3 nodes or less than 3 nodes. It can be 2, it can be 1. Okay. So that is the practice. So that is the theory part of this lecture. Why you are using groupByKey and why you are not using we are using reduceByKey, not groupByKey. What is the advantage of reduceByKey over groupByKey? Now we'll try to write some code and we'll try to visualize it. So we'll come to here my Pyspark. This is the same code where you are trying to do, or you are trying to use reduceByKey, and then we are using a connect operation. Now what we'll try to do, we'll try to increase the data size. Let me copy whole data, and again we'll copy paste here. This is data. So I am trying to increase the data. This is my data set. I will try to we are trying to do we are trying to create the RDT here, state parallel. Now we are trying to use map function here. So one thing I have to do, one thing I have to change here. So from here I try I try to collect this error also and this timestamp also. So what I can do, rather than assigning one, I can do one thing. I can again I will try to split this and I will try to do one. So what is happening here? So this RDD tool will hold the information like this. So the RDD tool will hold to hold information like this. Key one under list, it will be like this: 1, comma, timestamp like Tuesday, something like timestamp, insert a tuple. Same thing, error. We are trying to generate RDD like this, error, then timestamp again like this. That's what we are trying to do here. RDD, because using this split function, we will try to split this string using this delimiter, colon delimiter, and try to create a tuple 1. Sorry, it is disconnected. So 1, comma 1. So 1, comma 1. So we are trying to create one tuple using key and value. Now what we will try to do? We will try to use reduceByKey. Now what will happen? We always use reduceByKey on a key pair. Now how we can calculate these things? Because if I try to use reduceByKey, what will happen? Well, let me share my screen again. Copy this. Let's display. So what will happen? So if I have a data set like this, I, 1, a, 1, I, 1, a, 1, I, 1, like this. On top of the data set, if I used groupByKey, what will happen? Sorry, it's not like this. If you have a data set like this, 1 and then some timestamp, 1, then some timestamp. I'm set like T1. T1 means you set a date, like if a timestamp like this, 12/0/2024, error 12/01/2024, one error 12/02/2023, one 12/02/2021. If our data should look like this, if I use group by or reduce by, what will happen? Then what after using the group by, the data will look like this: 1, comma, or it will like this list, and this list 12/02/24. It will come. So this will come here: 12/02/023, comma 12/02/2020. It will create like this. So if I use group by on top of this data, our we will get new RDT and the data will look like this. Okay, no error, no, and also this error will come here inside the list. 01 24. Now, if I want to count the number of occurrence of one or error, how we can count? So you can count using the calculate the size of this list. If I try to calculate the size of this list, so in this list you have a three value 1, 2, 3. The size of this list is 3. So if I try to find the size of 3, 1 comma 3. So if you see here we have a 3 1 here or so the 1 is present 3 times. So we can calculate using this. So now if I write code code after this you can use the calculate thing. Now control save. Now what we'll try to do, we'll try to print x comma 0, then len of x 0, and control save, and if I rerun this we'll see the output. This is our key, this is the list. We are trying to find the length of that list. What I show you on that my pad. See, so we are getting 1 is 140 and error is 12, 112. If I try to print our x before that, print x, you will get a better understanding. So yes. See, we have one key, and inside this key we have a timestamp like this. Okay, timestamp like this. So we are trying to find the length of this list. And we are getting 140 and 150. So we go down, a lot of data is there. Okay, now what will I have to do? What will I have to do? We are using reduceByKey. Now we use groupByKey. Now we use groupByKey. We use groupByKey here. I try to find the size of this. Okay, now we better rerun this. We will get same output. The difference, there will be no difference in output. What is happening? Is this? Maybe we made some mistakes. GroupbyKey design again. Control Z, what is happening? Page group by key, page group by key, OEP, do save and rerun. It should work, but I am getting some error. I don't know why, but let's ignore this because we will get same output logically, okay? Because it should be key value pair. It should be key value pair. Maybe this is like it is trying to add these things, but problem is this. What is happening? Because that key value is string, that's why we are getting this error. But it's okay, no problem. You are getting this error. Let me check once again. Key. If I don't use lambda, it should also work. I don't use lambda here. Now it is working. Because if I use if I pass lambda here, now it was trying to add the string value, but because this one is a string timestamp, we cannot add the string, so that's why we are getting this error. If I don't pass this group by key, it will try to just create one list. Okay, so now I'll show you the output console. Use the console. If I rerun again, it will take time because we are doing reduce by key. See, one, and this is the Pyspark result iterable object. Okay, so we are getting one iterable object, and then we are trying to find that length of that list, we can say, because before we are getting wrong answer. If I use reduce by key also, we will get same answer. Reduce by key. If I use reduce by key, control save, we will get same answer. Okay, so reduce by key we have to pass lambda, and for reduce by key you have to pass lambda. Okay, then we can pass that lambda function previously what I do. But what I'm trying to say, if I now want to see our DAG, run this and see the DAGs, what I can see. Sorry for this mix up. Okay. But what I'm trying to see, if we want to see the error is 10 times, or one is 8 times, we see the DAX now, local force 404, I think. It will come here. You can see we have two stages because we are using white partition, so we have two stages here. If I come here, stage 0, where we are trying to load our data, we have a 12 partitions task. Why? Because so our data set is small, like maybe some 1 MB data is there. That's why when you have a data less than 200 MB, you have some So when we have data in local, so let me explain you. So if we have a 300 data in HDFS, then how many blocks will be there? Be divided by 128. How many? So into 2, 16, 4, 346. So maybe 3 blocks will be there. If you have a HDFS with 300 data in HDFS and block size 128 MB. But for our case, we have a one data set, maybe called 300 data set locally. If we have a 300 data set local laptop, then this block size concept will not work. So then how we'll do this? If I have 300 MB, we'll divide it by 32. The default block size, if our data is present in our locally, the block then we'll divide by 32. How many tasks will be there? Let me calculate here. So 300 divided by 32, enter. So we have 9.70 means 10 tasks. So we will have 10 tasks. So if we have our data set in my local laptop, then the block size will be 32. Block size is 32. So this is so that's why we are getting here. We are getting here 12 tasks. So actually if your data set size is, because our data set size is like 1 MB, if we go to code, what will be our data size? We see here maybe 1 MB maximum. So if your data set is less than 200 MB, some criteria is there, less than that point, then Spark will use the by default partitions, because in this Spark we configured the automatically there will be some default parallelism, like default partitions settings, default partitions. We have some default partition number in our Spark. For our case, in our system, the default partition is 12. I will show you how we can show this. How we can see this. So if you type sc dot default parallelism, this command in your Pyspark shell or Spark shell, you will get so I am getting 12. It means for default parallelism is 12. It means we will have 12 partitions. It means 12 tasks. In your system it can be 11. Okay, no problem. So if your data size is greater than 200 MB, then they will follow this concept. So if we have data set for 500 MB, then how many tasks will be there? And this data set in locally. This data set is present in my local laptop or local storage. Then we will divide by 3, and we will have 500 by 13. How many blocks? So sorry, 500 2. So we will have 0.7. So we will have 16. We will have 16 tasks. So that's how they're calculating those number of tasks. Now if I go to account, if I come here, and if I go to stage 0, where you are trying to do parallelization, you are trying to distribute our data among your cluster, if we come here, can see a lot of information like matrix summary of matrix minimum 25 percentile median 10%. It means so minimum time one node is taking only 4 seconds to execute our task, and maximum one node is taking 4 seconds. So like equally distributed, equally they are taking same time, no problem. So every person is taking time equally to to execute our task. So it is okay, it is good point. Now if we come here, sample size, so 93 MB. So 93 MB data is supplying minimum we are sending to our so we are, it means like one node is sending 92 MB data to another partitions. This is a minimum size, maximum reach 182 bytes. If we come here, this is the ID of executor. We have executor here. It is saying that it is taking 4 second time. Okay, then shuffle right means the every partition, every 11 partition will try to send the data to another, try to send the data into two partitions. Okay, to aggregate, to count the number of occurrence. So when they're sending data, how much data they are sending. So one is sending ID, the ID 0 means the first task is sending 94 bytes data, and second 187. This 11 1 15. Okay, so that's it. We are so that is the point here. So number of success tasks 12, and we are writing this much of data. So you can see the matrix from this from this localhost 40401 Spark Py. We got more information. Now if I go to, this is our stage 0. If I go to, if we come back to stage 1, if I go inside this, I'll show one thing. So we are writing this data when stage 0 is completed. We are writing this data 193 bytes. Spark 1 will read this 139 byte data. Now this data will come from here to here, stage 1. If we go here, we are getting, we have 12 tasks. Each task is taking 4 seconds. And if you see, observe, we are sending data only two partitions, this partition and this node. So if I come back, if we go back to 1, you can see, so we have data in every task. So every task is holding some data for stage 0. But when we are using groupByKey, okay, when we are using void transformation, you can see this, only two tasks is holding data. One task is holding 788 bytes and one task is holding 8680 bytes. So that is the difference. So here we are not getting parallelism. So other nodes or other partition are idle. So when you are using groupByKey, you should be careful. Okay, you should always use reduceByKey. That is the, so you can see this internal how they are supplying the data, like which task is holding which one of data. If you come here, if you have to come to local host 404, it means Spark UI. You can see all those information in Spark UI. You can see stages, you can see storage, environment, executor. See, we have total one executor. Okay, execution. So we have only 12 cores. So I already told you, number of tasks is depend on the number of like this executor. So this executor active one is a one executor, and the one executor can execute how many tasks is depend on the number of CPU core. In my laptop, in my laptop we have 12 CPU core. That's why this single maybe in my laptop maybe we have a 15 CPU core. So my executor can execute 15 tasks total. So this active one executor is executing. So this active one executor holding 12 CPU core. That's why it is executing 12 tasks. Okay. So it is complete 12 tasks because for stage 0 it is executing 12 tasks. Again for stage 1 it is again executing 12 tasks. That's why it is saying total 24 tasks. But total CPU core is 12. So it is trying to execute our task step by step. They are executing first 12 tasks. Then after those 12 tasks is completed, they are again executing another 12 tasks. So this is our input data. This is our supplement. This is this. You can see all those information. Okay. So that's it in this video. Now here we are seeing when you are using groupByKey and reduceByKey, we are seeing some wrong information, wrong answer because I am doing some mess up here. But for generally, if you use groupByKey and reduceByKey, you will get same answer. That's it in this video. I hope you enjoyed this lecture. That's why if you like this video, if you able to understand my explanation, you can like and share this video with your friends. That's it in this video about groupByKey and reduceByKey. If I use reduceByKey, also I can show you what will it will be same. ReduceByKey. So for reduceByKey, we have to pass this lambda function. So I'll pass this function. What we can pass here? Lambda x comma y and then we'll try to x we try to predominantly steer x comma y. What will happen? Let's see what will happen. That experiment. See, something is happening. It is working now. Wait. It is working like this, so it is wrong answer. Well, let me think what we can do. We try to do only x comma y to happen. And if we add these things, see we are getting a wrong answer here because it is trying to calculate the size of this string. Okay, but we don't want this size of the string. I'll fix this issue, like how we can get this word count, solution of this word count um, using reduce by key. So one way we can do that, we can assign one here, because for reduce by key you have to pass lambda function inside. For group by key we don't have to pass. That's why we are getting no error in that case. So if I use it like this one, now we'll get right answer. Now run the list of run. See, so getting 1 is 10 and error is 8. Now we'll see our DAX. So I am using reduce by key now. Before I used group by key. Now if I refresh, if I come to jobs, I have two jobs. Come to here. Go to jobs. So then first we are doing we are using parallel function to distribute our data set. Then we are using this white transformation, reduce by key, and then I'm doing our thing. Now if I see the details, we have 12.12 stars. This is a supple list. How many data is how much data is read by our stage 1, means our parallel function. Okay, so one thing you have to remember, when we are reading data from one place to another, or we are trying to shuffle the data from one partition to another partition. If the original value of the data set is 100 MB, after shuffling we will get some 90 to 70, like some less amount of data, because Spark will try to optimize that data. Spark will try to compress the data. So if the data size is 100 MB, Spark will try to compromise Spark will try to compress that data, so that size is became less. So less thing, if a data is 100 MB, after compression data will be 70 MB. After that, that data will be shuffled to sent to another partition. So we'll go inside this, it will come here. We have the same thing. See, so I'm this is, if we come to task 0 stage 1, so every task is holding data here. You can see this supple right. Okay, so every Spark is holding this amount of data, and the minimum time of one partition is taking 4 seconds to execute the task. So for minimum is time is 4 seconds, maximum is 4 seconds. It is good, no problem here. Okay, now if I come back here, stage 1, we are able to see that only task 8 is holding data, and only task 11 is holding data, because we are using reduce by key, which is it will try to shuffle that, it will try to send our data into one machine or two machines. This depends on the number of keys in our data set. So it is trying to shuffle our data and send to another partition. Okay, so other tasks will be ideal, because there is no data on those tasks, and we will have data on these two tasks. That's it in this video. I hope you able to understand my explanation.